Well, good morning. This is the worst possible spot in the agenda. You guys were all out drinking last night. I know, I saw you. I was there. So my greatest ally in this endeavor this morning is the caffeine you ingested a short while ago. And that's making its way in your body to that mushy stuff between your ears that's going to become 85 billion firing neurons. And I'd like to help that process along. And at CyCon, we have three kinds of people. We have technology people, we have law people, and we have strategy people. And I thought I'd ask you to raise your hands to see the proportions in the room. But, you know, in the spirit of doing some intellectual calisthenics, a brain warm-up, I'm going to take a different approach. So an electron walks into a bar. This one is going to be for the technology people. And the electron walks into the bar and he sees his friend from college, the proton, sitting at the bar, and there's the barman serving drinks. And when he walks into the bar, the proton goes, "Hey, John, so good to see you. Oh my God, you look so bad. What's up? What's wrong with you?" And the barman goes, "Yeah, John, you don't look so good. Look, I have a shelf of drinks here, all sorts of bottles. Just tell me which one you want." And the proton goes, "Yeah, tell me what's on your mind." And the electron looks at the proton, and he looks at the barman, and then he looks at them both, and he says, "You know, guys, I don't know. I was just minding my own business. I was there, you know, sitting at 2S, and then that blinding flash, I'm at 1S. Okay, none of the technology people are awake. Okay, that's pretty bad. You know, the energy levels, you know, so when the electron goes down in energy level, he gives a photon of light, and he feels drained of energy. That's really bad for the technology people. This is basic electrical engineering. You should all know this. Okay. So let's see for the others. So a lawyer walks into a bar. And sitting at the bar, having a drink, is a friend from college, the prosecutor. And the barman is at the bar serving drinks. And when the lawyer walks into the bar, the prosecutor goes, "Hey, John, it's so good to see you. Oh my God, you don't look so good. What's wrong?" And the barman goes, "Yeah, John, you don't look so good. I've got a shelf of drinks here. Pick a bottle. Tell me which bottle you want. It will warm you up." And the prosecutor goes, "Yeah, John, tell me what's on your mind." So the lawyer goes, and he looks at the prosecutor, and then he looks at the barman, and then he looks at both of them. He says, "I'll take the fifth." Okay, all right. You don't know how hard this is. You know, this is only supposed to make a third of the audience laugh, right? All right, but still way too many lawyers, I think, in the room that are awake. I don't like that. I don't like lawyers. Really, because, you know, they have all these hard questions that they come up with, so I'm going to talk to the end and not have any Q&A. And I don't like them because when I ask them a question, they have these long answers I don't understand either, so that's not good. But anyways, Sun Tzu walks into a bar. Actually, Sun Tzu doesn't walk into a bar. He makes the bar wants to be where he is. There you go. So, okay, you're warmed up. That was 3 zero-day jokes, and I'm having my very own little Stuxnet moment right now. All right, resilience. This community has known that protection has never been possible. Perfect security is not possible. That, in fact, reasonable security is difficult, and in recent years we've realized how difficult that is. And that we know now that we're going to have to survive cyber attacks, and we need to prepare for that. And resilience in boxing has to do with the capacity to recover quickly from difficulties. It's based on stamina, confidence, and willpower. And we talk about resilience in cyber, we really think about backups, alternate facilities, and spare capacity. But it's also so much more than that. It's this ability, of course, to have all of the people involved in an incident work together and recover quickly from the damage that's being done. And protection is about 95% technology and 5% human behavior. But once the protection is defeated and the systems are compromised and you're dealing with an incident, your response is really 95% human behavior and 5% technology. So how do we deal with that? How do we improve our preparedness? How do we become resilient? Well, if you ask the military, you do run exercises. And so most people have been focused on cyber exercises. But the big question is, how do you get the best for your money? We often ask, how much is an exercise? And it's a difficult question to answer. And really, I would like to talk to you a lot about how to make the exercises be really worth the money you're spending on them. And to do that, I want to make sure that we cover two main focuses. First is thinking about the future, planning ahead. And the second is about, scope and ambition and actual level of funding. When it comes to the future, we've heard a lot of talks this week and before at all conferences about how the society has become increasingly digitalized. The Internet of everything, smart homes, smart meters, smart cities, smart everything. And we're getting everything to be connected. And when a nation has to start to think about preparedness and resilience in cyberspace, you have to start to think at some massive effects that could happen. And when it comes to smart cities, smart homes, the little things that you wouldn't think of can matter a lot. And what is the government going to do about it if some attacks affect a lot of the population? And some of these things are not necessarily all the critical infrastructure and all of the attacks against military systems. Those are fairly well understood, fairly well covered. But for a government to be prepared, you also have to think about different things. Things like, your connected fridge in your house. So if there was a common vulnerability in all the fridges and they got all attacked, what would happen? What would the people do if they couldn't store cold food? And what if that attack was coupled with another attack on your supply chain for your food? What would be the reaction from the people? What would the government need to do? How would you handle that? What would be the roles, the responsibilities, the decision-making processes, and the coordination that you would need? We also know that we're getting more self-driving cars and trucks. I like this picture because, it's pretty obvious this truck is not going to be driven by a human. I don't know if it exists in roles, but I found the picture pretty, and it explains my point. Once you start to deploy all of these, and they're everywhere on your road networks, and they're all built, to be economic, they're all built using common components. What is going to happen if there's a common vulnerability that an attacker can find? And what if he can actually disrupt these vehicles? And all that's needed is that you actually just park them. You just make them stop. And then you defeat the software. You do something where it can't start again, where you physically have to go to every truck and tow it away. And if you park it side by side on 2 lanes, or if you park it on an exit, you're going to, if you do that to all of the self-driving trucks, you're going to paralyze the transport network. What are you going to do there as a government? What's going to be your response? How do you deal with that? What are the roles and responsibilities? Are you going to send 1,000 self-driving tow trucks to get them? How do you get these things off the road? These kinds of impacts are different, and this is coming towards us in the future. It's not here yet, but it's coming very quickly. We also have some biosensors now. People are starting to put these chips under their skins, and they're doing different things. You can do identification, authentication. I've heard of a little chip you put in this part of your hand there, and when you grab the handle, it unlocks for you because it recognizes you. But I've also heard that they have found a way to put some sensors in people's head. And for people who are paralyzed and can't move any of their limbs, they're now able to control a robotic arm just by their thoughts. And that arm can grab a bottle of water and give them water. They've also done some experiment with lower life forms, mice and stuff, where they're able to shoot some thoughts into the brain. So all of these things are growing, and they're not controlled. There's nobody who's overseeing this entire program of all these things that are happening to our digital society. These things are being pushed by the commercial sector. So, governments have to be prepared for anything that can happen. And when we start to put some chips into our heads, well, where are these chips coming from? And we're putting these chips everywhere. I think Thomas Doolan yesterday spoke about the chip manufacturing process, and there's so much more to be said about that. This is one of the machines that makes these chips. If you study this a little bit, you'll find that that supply chain is pretty complicated. It's very, very, very technical, and there's actually only a few sets of components in that supply chain. The software, the hardware that's used to make the logical design, the physical design, and all of these steps that are quite complex and specialized. So as a country, you can ask yourself, who makes my chips and what's in them? That's a big question, and if there was something to be found, then how would you deal with that? We now have a bit of experience now with Spectre and Meltdown, but those were design mistakes in the architecture. We don't believe they were introduced there maliciously, but what if, as an individual, you're putting these chips in your body, or you're using them in your phones, or every part of your life that's becoming more digitalized? And then we have artificial intelligence. I like this picture, and there's much to be said about artificial intelligence. But I won't, spend too much of my time on that because there's so many more people who know more about it, and you can hear from them. But the reason I like this screenshot from the 1984 movie Terminator is because when that happened, you saw how the Terminator thinks. You saw the image he sees, and then you had the overlay of various sensors. And it really gave you an understanding of how AI functioned. You're sitting there and you're seeing he's recognizing the shapes of motorcycle, the year they were made, recognizing targets, he's figuring out what he's going to do. And you have that, oh, I know what AI is. Oh, wow, I can understand, I can predict. Oh, I get a feeling for what this thing can do. But not a lot of people stop to think about, is that how it actually works? There's no sane AI developer that's going to come up with a video image, overlay the sensor outputs, and what would the AI do with that? He would have to look at it and then do optical character recognition and recover the digital numbers? It doesn't make any sense. This is an illustration of how it works, and it gives you the warm and fuzzy about, oh, I understand AI, but you don't. Nobody will. That thing is going to get so complicated, so large, and so capable that we're not going to know what it is. So be very careful when people explain to you AI, because you get that warm and fuzzy feeling, oh yeah, I get it. But really, do you? Once that thing starts to roll and think, then, are we able to predict what will come out of it? So there's people who are optimistic, pessimistic. That's not my point. My point is this is going to be very hard to predict where this is going to take us and what can happen with it. And then, of course, we have cyber attacks against belief systems. And I really think that is, something we've seen recently, meddling with the elections and things like that. That's really a huge risk. And I think that this is going to increase. And for nations who are trying to get prepared for more of this, one of the greatest challenges is this concept of what is civilian responsibilities and what are military responsibilities. And that's extremely difficult. And you hear a lot in this conference about international laws and the use of force and what's constitute an attack and these things. And when you think about cyber, a lot of people are trying to paint it in our understanding, civilian versus military. This is really, for a lot of cases, a black and white situation. If it's a military responsibility, then you know exactly how that functions. I think the countries that are going to successfully handle crisis and cyber incidents are going to be those that don't make so much of a distinction between the two. The countries that are able to look at cyber and not think about military versus civilian, that they're going to come up with an integrated fabric of response options, of fundings, of programs, of exercises that are going to be actually addressing everything in one continuous spectrum. And this is going to grow, these things. For example, this technology is called reenactment, and this is available probably in open source software that you can download. You take a target actor, you put someone, and you start to speak something. And the software will actually look at your face and replace all of the same visual movements on the face and make you say something, make the other person say something. And this is dangerous because you can use that to make a politician say anything. And then you look at facial expression recognition. Those are also open source tools to do that. So you're able to recognize the feelings that people have. And if we take this a little bit further, and we look at what's happening in our homes when we're installing all of these devices that are listening to us, that we can give instructions. And we saw recently that they're always listening, and sometimes they misunderstand what we're saying, and they then do something. Recently, someone's files got sent to a contact in their address book because some of these devices were listening and misunderstood what was being said. And so there's some problems there. Eventually, I think it'll go beyond just microphones. There'll be cameras, and these cameras are going to have facial expression recognition, and they're going to feel your mood. And so you get into a situation where you can have a politician on TV trying to give you a message. And because all of these social services, social media, are really trying to get individualized messages, they're going to be able to feel the mood in the room. You might be talking to your spouse. You might be angry or you might be happy. They'll recognize this, and they'll make that person say something differently. You know, let's not even think about the malicious case. Let's just think about the non-malicious case of saying the same message, but using different facial expressions, different tones and everything, just to make sure that you're in the right mood to absorb that information and be convinced of it. I'm not saying this is going to happen, but what I'm saying is that these technologies are going to be there in our houses in 2 to 3 years, and this will be possible. Whether it happens or not, I don't know. But it brings the whole set of issues about, you know, attacks against a belief system to a completely different level. And once again, we don't know if that's going to be the responsibility or at what stage it becomes a military versus a civilian responsibility. So the future. Well, the future is hard to predict, and it's hard to come up with a good picture of the future. I kind of think that, you know, with what we like from reality shows and, you know, increasing digitalization, it's going to be some weird mix between The Matrix and the Hunger Games. But I think this picture is great because it shows that when you're trying to plan for preparedness, you don't want to think in the past. You don't want to think about the attack that happened last year and then make an exercise that will run in a few months, and then you'll get the results you know, in a few further months, and then you're really exercising for something that's 2 years old. Planning for the future is an effort. This climber had to go up the hill. He had to pack his equipment, and once he's up the hill, he can see the full landscape. So it's the same thing. If you're going to plan something, make the effort, get the information, do the consultation, and then get up there, you know, where you have a full view of the land, and you can look at the stars, and you can find what really matters and where you fit in the universe. So it's important to make an effort when you're planning for your cyber exercises. And then people ask us how much our exercise is. Well, we kind of think that this is hard to answer. And we have this problem in cyber that we don't use the right thinking about money. And recently I was advising a few countries on a new novel cyber capability, and we talked about the money it costs, and then they kind of said that's expensive, so we worked to reduce it. But the whole thing got me thinking about what does it mean to be expensive in cyber? So I actually started to think about other domains, like the military domains. And I latched on to this missile, an air-to-air missile, the AIM-54 Phoenix. And that missile was built for one specific purpose. At some point in the 60s, the Americans determined that the Russians had cruise missiles with nuclear tips that could be launched from bombers at a distance. And they had so many of those that they could overwhelm the defenses of a carrier group. So they had this tactical flaw that these missiles could come in and destroy the carrier group. So they said, we need a long-range missile. So they started to develop the Phoenix. And the Phoenix was operational from 73 to 2004, so 31 years. And it was a pretty big missile, half a ton. It had a 60-kilogram explosive head. And the only aircraft that could carry it was the F-14, could carry 6 of these. And the cost of each missile is about $500,000, okay? And over the years, there were very different versions. They built about 5,000 of these. So in total missile costs, we're talking about $2.5 billion, about $80 million a year to get this missile. But you know, the point of a missile is to take 60 kilograms of explosives and bring it onto the target. And when you're trying to figure out the cost of things, you got to follow a certain logic. The whole missile at 500,000 exists only to bring that munition onto the target with at a range of about 100 nautical miles. But when you think about it and you extend that logic, the only purpose of the F-14 is to bring the missile close enough so that it can actually travel the last 100 nautical miles. How much is an F-14? Well, somewhere around 38 million. How many do we need? And everything like that. And then you extend that a little bit further, and well, yeah, but I need to bring the F-14 closer to the target, so I need an aircraft carrier, right? You get the meaning. When you add all of these costs up and you're trying to find the cost of bringing that 60-kilogram explosive onto the target, you end up with a huge amount. So we're talking about 80 million a year, plus this considerable amount of indirect costs to bring that munition onto the target. So that's the kind of cost we're talking about. This is one specific tactical scenario, and the solution has this cost to it. So was it really successful? Well, turns out the Americans fired a couple of these missiles, but they never really engaged any targets or killed any enemy aircraft with it. They fired a couple, they didn't work. The Iranians also bought the missile, and they had more success with it. But all in all, it barely wasn't used, if you can say, for its intended kill purpose. So 80 million a year for 30 years to fill a very specific problem, possibility of a carrier group being attacked by a nuclear-tipped cruise missile launched for a bomber. Is that expensive? I think most defense people will tell you, no, it's not expensive. But if I talk to you about a firewall to protect a nuclear power plant from a specific type of attack and make you pay $80 million for 30 years for it, you have a problem with that. It just doesn't ring a bell. It doesn't work. And that's a problem when we think about the cost. It doesn't have to be that amount of money for cyber. Cyber is much cheaper, but we're still thinking of it, in terms of IT equipment and IT training. And that is really a flaw. So it needs a better funding. And I think that now that the masters have called cyber a domain of warfare, operators have gotten this message. But the financial people really need to start shuffling some budgets around to give more money. Start to think about this kind of scale of capabilities and this scale of funding. Not in identical numbers, of course, but to be proportional to the impacts and the effects and what we're talking about. So now we're into cyber exercises. This is a picture of this room 5 weeks ago. Lock Shields 2018, a very, very advanced exercise, one of the largest in the world, ran extremely well. And congratulations to all the organizers of this. It was a significant event. Very advanced capabilities were demonstrated during this exercise. But Lock Shields is a very specific kind of exercise. It's a competition amongst the nations, the participants. And when it comes to preparedness, it's a little bit something different that you're looking for. You're looking for something that is customized to your specific needs, to your nation. It's about being prepared for a set of realistic cyber incidents that can happen to your nation, your organization. And this requires a different kind of exercise. So in our experience, the key to being prepared and developing and building up your resilience has been to make the exercise to be specifically customized to your needs, to your organization. It's about your roles and responsibilities. It's about having everyone who's participating in an exercise see themselves in a futuristic cyber crisis that is actually quite relevant to what they do, to their organization. And this requires a lot of thinking. It requires a kind of futuristic planning and thinking that I spoke about, what it is that can happen to my nation or my organization, how could it happen? And it's so much more than training. And we have done this a number of times, and what we've come to realize that even the process of planning and exercise is of significant value. Because you're not trying to take some generic IT training. You're actually making something specific for the organization. You're looking at what are their threats, What is the value of their assets? What would an enemy come and do to this organization? What would they look for? How would they prepare? How would they conduct an attack? And you're working through all of this, and you're looking at the participants you're going to bring into the exercise and saying, what am I going to make them do? What it is that, that I want to achieve here, and how will that function? And we're talking about large-scale national exercises where everybody's involved, decision makers to technicians. And the whole point is to bring them into that situation where they have to work together as a team. That is how you're going to get that preparedness. It's having a clear understanding of everyone's role and responsibilities for the scenarios that apply to your organization. It's being able to do timely and accurate communications. It's about solid decision-making. It's about excellent coordination for all the response and recovery actions that you need to do. So when you build that scenario and you do this analysis and you come up with something that's realistic, you are actually doing some kind of risk assessment, some kind of analysis. And the value of the exercise plan in itself is immense. It is a study of what could happen, and even just planning an exercise gives you great value. And then when you run it, you really see how well people do. And from that, you learn all these lessons, and you change processes, you change responsibilities and communication means, and you deploy new technologies and capabilities. So it makes a real difference, but the exercise absolutely has to be customized. This is how you maximize the investment that you get out of it. And it has to be realistic, and that requires a big effort. And that's why we talk about having the proper funding for this. And General Patton said, you fight as you train, so that's the military wording of at the time. If you say it today, you'll respond as you exercise. So it's really important to do these things and to do them well. And when you ask yourself, you know, is this expensive or not, don't think of it as just some more IT training. You have to look at it as something completely different. And you have to actually sustain it. You can't do just one and say, oh, we're done, that's it, we're ready. It's something that has to be built into a program. So if you remember anything from this presentation, I would say that you should remember that the future is unpredictable, completely out of control, because technology has been thrown to us. Only market forces are at play now. It's not driven by the government. And it's coming really fast, faster than you think. And if you need to be prepared, remember that 95% of your capability to respond to an incident is going to be human behavior. You need to focus more on this. And to focus more on this, you can't just take some generic training and hope for the best. You have to develop exercises that are customized to your roles and responsibilities, structure, method of working, risks, and value, and the business operations you're doing it. And the only way to truly become resilient is to have a program of these exercises that runs over the years. And to conclude, I would say that here in Estonia, you're in a very special place. This is the host nation for two of the largest, most complex cyber exercises in the world, multinational exercises, Lock Shields, which I mentioned, and Cyber Coalition. And in this country, you will find a disproportionate amount of knowledge and capacity in the government, the Ministry of Defense, in civil departments also, and in companies, in the industry. So take what they have to offer and use it to your advantage. Come here and get the knowledge that they have accumulated over years of running these complex exercises, and take it home and build your own programs to become resilient. And this concludes my presentation. Thank you. Thank you so much. Yes. Good. Thanks.
We have time for one quick question, perhaps.
I said no questions from the lawyers, though. They don't like the lawyers.
From the lawyers. Only jokes from the lawyers, but can I see a hand? There is one. Yeah, please.
My name is Gabriel Jacobson. I am not a lawyer. Question. You talked about specific target. You called it beliefs systems, which is certainly quite new quality of targets apart from physical, informational, or other targets. So, and your talk is titled as Resilience and How to Manage, how to Maximize the Return of Investment. Taking this specific target, the belief systems as a target, what kind of challenges and kind of technological issues, what you can see here?
A great amount of technical issues, technological issues, and challenges. And I'll try to answer quickly because we have to move on to the other talks. But the biggest difficulty is that all of these notions, these belief systems, the whole concept of fake news and elections and how society functions, is in the hands of large companies now. And how do you protect that? And these are global. This is the social media that influences our lives. We get this information from the web, and we'll get more of it. And all of it is customized, individualized, based on algorithms that decide what should we see. And this is the biggest risk. And so the challenge there is a little bit about the regulations. How do you protect that? We're not talking about, well, okay, you have to be concerned about cyber attacks that will destroy critical infrastructure. But I think that's manageable. That's the easy part. When you talk about not so much cyber attacks, but manipulation of social media, then it's a completely different story. And is that an attack, and how do you prepare for this? And the challenge for governments is that this is really hard to regulate. Really hard to regulate. And regulations take a lot of time, and regulations are national, and these issues are global because these platforms are from, multinational companies. I don't know what the answer is, but I think it is one of the greatest challenges. You can't just look at, attacks against critical infrastructure, and these things about belief system is completely new game, something completely different.
Once again, thank you very much.
Thank you, Anne.
And thanks, CoreTime, for the cooperation.